Yes. Hello, dear students. Good morning, everyone. Uh, in your class 10 textbook chapter, in the chapter number 1, we have this topic, that is Euclid's division lemma or Euclid's division algorithm. So at first we have to study about this theorem. We have to say this is a theorem, and first of all, to understand this chapter, let us see what does this theorem states. So let me tell you the statement. There is the statement: if we take any two integers a and b such that a is greater than b, any two integers, then there exists unique integers q and r such that a equal to bq plus r, where 0 is less than equal or equal to r and r is less than b. So this means that whenever we take any two integers a and b, then there will be two integers, there will exist two integers q and r satisfying this condition, that is a equal to bq plus r. And there is another condition for this condition. Okay, so this condition tells us that the value of r at the minimum, it should be equal to 0, and r can be greater than 0 also, but r should be less than b. And here, in order to understand fully, expansively, we can take an example of some figures. Suppose we take a equal to 7, a very simple number, and the integer b we take it as 2. And now let us see. Let us divide 7 for b by 7 for a. This 7 is for a, we are taking, and for b we are taking 2. Okay. So let us carry out the division of 7 by 2. So what do we get? Let us see. 2 3 times is 6, and we get the remainder 1. So in this divisional sum, let us see here, that is 7 equal to 3 into 2 plus 1. You see, 3 times 2 plus 1 is exactly 7, isn't it? Can you follow? Yes. So this statement is just in this form, you see. That means in our this divisional sum, this 7 is the dividend, and that is a we are taking, and this 2 is what? 2 is for b we are taking. We are taking b equal to 2, and when we carry out the division, we get 3 as a quotient and 1 as the remainder. And this, which is just similar to this statement, it states that dividend 7 is equal to divisor 2 into quotient 3 plus remainder 1, isn't it? So A equal to BQ plus R. So we get this from this statement. So this statement is known as Euclid's division lemma or Euclid's division algorithm. Sometimes in the examination also it may be asked by giving only one of this, either this or this. So please don't confuse about the question whether it can be about Euclid's division lemma or Euclid's division algorithm. So both of them carry the same meaning, so don't confuse if any one of this is given. So in the examination for 1 mark, it may be asked is a question. Let me tell you the question. States Euclid's division lemma or Euclid's division algorithm. So at the time you have to give this statement. And one more thing I would like to mention to you is that here you may not be familiar. You may not be familiar about this word unique. This word unique. You see, unique means only one, not more than one. For example, so in order to understand the word unique, let me give you an example. Suppose you are wearing a dress which is very particular in color, and the color of your dress is not dressed by any one of your neighbors or somewhere, then we can say that your dress, or someone can say that her dress is unique. That means your dress is a very particular one which is not used by any other friends or persons. So can you follow me? So unique means only one, and there is no any other similar to that. So try to understand properly, and it is better to, first of all, it is better to carry in memory this statement. So if you carry in memory, then automatically you can understand it better. So carry it in memory. And in your class 10 textbook chapter 1, we are going to study another theorem. So after this, let us come to this theorem that is popularly known as fundamental theorem of arithmetics. Fundamental theorem of arithmetics. So the statement of fundamental theorem of arithmetics is every composite number can be expressed as a product of primes uniquely except for the order of the primes. There are some terms, so let me underline them. Composite primes uniquely and the phrase except for the order of the primes, except for the order of the primes. So this underlined parts and phrase, let me explain to you. Now pay attention. So about this theorem, composite number. Composite number. In this theorem, we use the word composite number. This composite, we cannot write the statement without this composing. Okay, so this composing is very important. So what do you mean by composite number? Composite number is a number which has more than two factors, that is 1 and the number itself. Okay, more than 1 and the number itself. For example, so take this number 6. What are the factors of this 6? What are the factors of this 6? The factors are 1, 2, 3 and 6 itself. 6 itself. So how many factors has this number 6? We have 1, 2, 3, 4 factors, isn't it? That means 6 has more than 2 factors. So such numbers are called composite number. Can you follow me? And there are many composite numbers, infinite number of composite numbers. So you can give so many examples of composite numbers, isn't it? So less than 4, that is less than 6, that is 4, and we have 6, 8, 9, 10, etc. See, there are many composite numbers like